Alright guys, you're welcome to my next tutorial on the Python series. The last time we considered the inheritance in Python and how you can create a child class that will inherit from the parent class. We talk about you can define an attribute and method in the child class, which is very similar to the same way you define the attribute and method in the any class in the parent class. We mentioned that it's very important that you use a super keyword so that you can pass the parameters that are common to the between the two classes. You can pass the parameters of the child class to the parent class to be handled in the parent class, since we already have it handled there. And so we mentioned that you can define your attribute, and like in this case battery size is the attribute that is uh, specialized to the electric car, and the described battery is the method that is peculiar to the electric car. So today we shall continue on the inheritance and some of the functionality there. One important thing is how you can override a method that you have inherited from the parent class. Don't let us forget that we mentioned that everything that is in the parent class is available to the child class. Occasionally, some of those things you might want to redefine them. That is, you want to delete them or override them. So the basic way of doing that is you just declare the same you just declare the signature to be the same, and you re-implement the logic the way the child class wants it implemented. So what I'm trying to say is, for instance, let's say in the parent class car you have the method fill gas tanks, and you know that that method does not make sense in electric car. So what you just do is that you redeclare the same method, this is the same signature, and you just now give a different implementation in the body of the method. And that's just that simple. We can also use instances as attributes. This will normally occur as you solve real world problems. When you discover that what you have actually taken as an attribute is beginning to have more and more information, it will be better to encapsulate that as a different class. And so in that case, instead of just having it as an attribute, you may want to have it as an instance. So for instance, here where we declare our battery size and give it a value, you may have more and more information about battery that you may want to just now get the battery size. So you may just instantiate the battery information as an instance. So let's see how that is done in an example here. So for instance, you may now want to create another class called battery, which is going to have its own init and its own attribute and methods. So for instance, this class battery takes in the battery size, and it has an attribute of its own, which is the battery size, and it has a way for you to describe the battery. So when you now get into the electric car, when you need to create the attribute for the battery, you can just create an instance of that class battery, which we normally do with this format. So once you have that, you can just pass in the parameters of the whenever you need to instantiate this battery, you just call this class battery, in which you instantiate all the information that you want to know about your battery. So this attribute battery, the information about it is encapsulated in another class, which has everything that you need to. It's a very intuitive way of writing programs. So let's look at an example of that in this. So let's go to our example and see here in the code we already have our parent class, which is car, and we have the child class, which is electric car, and we have an attribute instance, which is battery. I hope we begin to understand the structure of our code now. So the electric car is inheriting from the parent class car, which means it has all the functionality provided by the class car. And so we are redefining inside the electric car, it has its own specialized attribute, which is battery. But this battery attribute is not just taking a singular value, now it's taking an instance as its value. So the instance is of class battery, which we declare here. And this class battery has its own feature attribute, battery size, and it has its own method, which is describe battery. So we can see now that when we want to create an instance of my electric car, which is my Tesla, we can just apply the information that is required by the parent class car, since we push that information using the super to the class car. So we create an instance of it. So at the moment of creating an instance of this my Tesla, what you will notice is that this reference, this instance my Tesla, also has this attribute called battery, and this attribute battery is its information is encapsulated in a class called battery. So now let's see that we run that. So if we run this, you see it gives us the information. So this get descriptive name is coming from what? Is coming from the parent class car, which you have here. This is the get descriptive name. So it just evaluates this functionality and it gives us the information, which is this, which is what we have in here. Okay, and when you get to this my battery, so we are now using this same reference to access the electric class attribute. So the electric car attribute is the attribute battery, so which is going to give us an instance. So that instance we can now use it to access its own feature attribute or its own attribute or its own method. You can see that. So that is what the dot product is. This one gives us an instance. My Tesla dot battery gives us an instance. Why? Because we have declared it as an instance here. So this we return this. So the whole of this is going to return an instance here. So because this is an instance, we can now use that instance to call its own available functionality, which is describe battery or battery size. Alright, so let's now see that it's something very important here. You see here that the battery size is declared as 75 here. So this is a default, so that when you instantiate this class battery and you don't supply any instance, any argument, then it automatically default the battery size to 75. And you will see here that when we are creating this my Tesla, we never made any attempt to initiate the battery, the value here. We didn't put any battery in this class electric car, so that is why that is defaulted to that. So let's see another example of that so that we can better understand what we're trying to say. So let's look into this first. I want to create my Tesla and it's got 2, and so I am giving it let me say BMW just for an example, and I say my is BM electric, and so let me say the year is 2020. Okay, so what do we do with that? So here, as we get that, here we already have inside this place initiated in this list, in that my Tesla 2, we already have the model, the name, and the year. At the same time, we also have this battery's information defaulted to 75 based on the way this class is instantiated. Because by just having this line of code, a lot of things has been executed. One is that this class car has been executed. Another thing is that this class electric car has been executed, and because of this call to battery class here, it is the whole of this also has been executed. I hope you understand, which means that this also battery size has been defaulted to 75. So that's what we're trying to say that. So if I say, for instance, now I just use my Tesla. I said my Tesla 2, and I say dot. I want to add, because I know it's an electric car, and I would just want to 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 retrieve its battery information. So if I just click on the battery, you will see this is going to give me what? An instance. So this is an instance. This is actually an instance, and it's an object. So in Python you can check the type of it with this, and so this is actually an object. So um, so what do we now do to be able to access its 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 functionality? Because this is an object, is called to battery. To be able to access its attributes and function, we just put another dot, which will give us what is available there. So if we just say battery size, then that will just give us 75. Now let's say I now want to change that battery size to another value. So if I do that and I change the battery size to 90 and I run this code, so that changes the battery size. By the time I come again and I rerun the code, it will have changed the battery size to 90. So as you can see, the battery size has been changed to 90. So that means I'm using the reference variable my Tesla 2 to be able to access its own attribute battery, and through that instance I'm using it to access the class battery, and through that I'm using it to access its own attribute battery size. You can see how things work there. And then if you want to use this same to just get the descriptive name, and you will see that by the time you put a dot and you say the describe battery, then it will give us that it is since this is a method, so by the time you give us that is 90, because we have changed it to 90 again. I hope that makes sense. Alright, so that is that about how you can continue to have different information about your more details about a subclass or a child class attribute. So you can continue to do that as we may want. So another thing you can actually add is you can add in the class battery, you can have a get range, so just to be able to have some more functionality. Here, for instance, if you have declared your battery size just to be okay, so we have inside our class battery here. So you can have a get range declared inside this class battery, which is just to add a more functionality. So it will access this battery size and make some logic decision about it. So that's what is happening inside it. So inside the class battery, they're declaring a method called get range, which we use to access its own feature attribute inside this place. And if it is a particular value, it changes the range. If it is not, it gives it 315, and it's printing out that range. So that is how you can continue to build on that. So thank you very much for listening. The next time we shall look at shall wrap up this looking at how you can model real world object. Thank you. Please give us a like if you have benefited from this, and we appreciate your comment as well. Thank you. See you in the next one.